Okay, let's continue with our lesson. Now we go to the technical aspects. So we talk of our, uh, we are still on electrical quantities. So let me share my slide. Right. So we are there. So we talk of basic electrical quantities, and it we are dealing with our simulations. What do I mean by simulation? The other day I was mentioning to you that you can still play football with a computer. As I said, some people even use that to win bets. But the real thing we want to see is that you should wear a boot, hose, a jersey, and other things to go to the field and now play for us to see. So you see, football is in two ways. Forget of the theory aspect that you learn in the football academy. Let's look at the simulation aspect where we use computer game. You see, some of the academy, the coaches in the academy, they use the computer games to teach them how they are in the classroom. So the man will be playing the game for you to see. They'll be showing you the positions, how you should strike, how you should overpower your opponent, how you to check your opponent and all those kind of things, the formations and other things. But after it, they don't leave it there in the room. They go out to play. There you experience the sun, rain, colleagues hitting you here and there. You see, that is the real thing. And as I said in the earlier video, you see, that is how every tech student should behave. So what you design on your PC shouldn't be all. Now send it to the market or the society to face the challenges over there. Fine. So I'll take you through these simulation softwares. The first one is Multisim. Multisim, you can download the 12.0 version, or you can download the 14.1 version. So I don't think you should have problem. As an IT student, you should have the ability to download softwares, get the cracks, and now install. But then if you are facing issues, I think I have to use, I don't want to uninstall my softwares. One day, I'll try and do that in class, or maybe my first class, my first lesson. This is what you do. So all the introduction that I would have been doing when I come for the first class has already been covered in these videos. So next week, when I'm coming to class, please, this is an advice to all of you, all the classes. Please make sure you get these two softwares that I'm going to mention. I'm talking of either Multisim or the next one, which is Proteus, ISIS, Proteus. So Multisim or Proteus, have these two softwares installed on your machine. You see, when I come, I'm not coming to teach you any theory. The first thing that you do is the practicals, which is a simulation, because I've already given you some small theory talk there. That's when we started the electrical quantities. So when I come, I'm going to start with the simulation straight away. When I come, please, those who are able to install and you still have the setup, help me to help your colleagues or support your colleagues to also install. So for the first time that I'm meeting you in class, if you are not able to install, it's not a crime. Come with a laptop. The only thing that I'll take as a crime is you coming to the class without a laptop. Please, if you don't have the laptop, it's better you stay home because it's purely practicals that I'm coming to do. Because the theory aspect, you've taken it online. So come to class with a laptop. I'll come with the software, and I know colleagues will also come with their versions. Then we all install them on the PCs because we are coming purposely for that. So if you cannot get a laptop, please don't come. But you can still get because you have colleagues that are having laptops. So you can borrow them and come. So make sure it can be powered very well. Then we come and work on them together. So we'll be installing these two softwares. We have Multisim and what Proteus. Multisim is for the basic electrical works that we'll be doing, but Proteus is for the digital electronics. You see, your content contains two things. We have the basic electronic system, then you have the digital electronic system. So finally, we will do our main physical practicals. That's after medicine. So your logbooks to I'm on them. I think they should be ready by next 2 weeks. For next week, we will install our softwares. But for next 2 weeks, I think next 2 weeks should be theory throughout. Then the following week is when we'll be doing our practicals for you to be recording in the logbooks. So that is it for now. So let me share one of my screens. That is for the multisim. So let me stop sharing this. Then I go for uh multisim, yeah. Good. This is the interface for multisim, ISIS. So when you open it, it's just like any software that we deal with. Word, PowerPoint, and all those kind of things. We have file, edit, view, all these things. As time goes on, we'll be using the tools and you'll get to understand them more. So let's see. There are some few circuits that we shall be dealing with, but few components that we shall also be using in this course because this is for IT, not for electrical. So assuming I want to build a simple circuit whereby I want to have source of energy, I use a control device, then I should be able to have a load. What do I mean by load? An example of a load can be a radio, a bulb, a heater, or whatever. So let me try and do that. So what I know is that I need a source of energy. But then in the first place, let me say that this is the working area. You can choose to allow this grid to be there, or you can go to view, then you go to show grid. You can take off the grid, then the whole thing becomes plain. But I wish to be working with the grid, so I'll let the grid be there. Now, what I can do now is let me click here. Immediately you click here. This button here is for the components that you'll be dealing with. So when I click here, it will bring me to this section. If you install your software and install it well, immediately you click, you see these things pop up. But if they don't pop up, it means either you didn't install it well or the libraries were not installed. So with this, I need either AC source or DC source. But since we are still on the basics, let me go to DC power. And you all know this symbol to be a battery or a cell. So I go to OK, then I click again for it to be like, because if I hover the cursor, you see it will be moving with the component. But when I click this way, it will be left there, then it will bring me back to this window for me to choose another component. So the next thing, after I have the battery, the next thing is a control device like a switch. So that is why I can come to this source here. Go to source, then I go to basic. Under basic, I'm going to see a switch there. So I click on switch. So we have different type of switches over here. You see, different types. But I want the first one, that's the basic. Then I click on OK. Then I come and place that one too. The next thing that I should deal with is the load, of which I said is the what? The lamp. So when I go to basic, I'll go to indicators. Then you see the lamp is there. We have voltmeter, ammeter, probe, buzzer, lamp, virtual lamp, hex display, and what? Bar graph. So I can take the lamp. So when I click the lamp and bring it, I can now close the window because I don't need anything. But then when you are designing anything in this particular software, not the other one, always add something called go to the source. That thing we call it a ground. It also look like a battery, but not a battery, it's a ground. So always pick it and add it to your work. Always do that for me. So now we want to now wire the circuits, or you want to connect all the components, because now I've been able to place all the components. So when I click here, then I come back and click here, it will join. When I click here and come here and click there, it will join. Click here, it joins. Click here and click here, it joins. So now I want to see whether this lamp will come on. That is when I try to switch on here. But when I switch on, I don't see any light. Why? Because the circuit is still in the design mode. We have design mode and we have simulation mode. So now that I've finished, I can click on, when you come here, there's a green button here. When you click on it, it will be simulating. Or you can look on your far right here. We have 0 and 1. So when I toggle to the 1, it means the thing has now come to the simulation mode. So when you walk down, when you look down here, you see this time, the transition time working. Then you see these green progress bars. It tells you that you are now in the simulation mode. When I take it back to 0, the simulation mode will go away. So let me take it back to the simulation mode. So now when I click here, the button will go there, the switch will close. So when I do this, you see the lamp has come on. When I take it again, the lamp goes off. So it means I've been able to build a simple circuit, electrical circuit, powered by a 12 volts battery. Then I have my 12 volts lamp or 25-watt lamp. Then I have it. So that is it. But there's something I want you to see. Maybe you want to build the same thing for somebody. You see, this one is simulation. But how do I know whether this battery that I chose was a good battery? Because if I do this and it is now okay, then we go to the implementation stage, as I said. But when you are successful in the lab, you now go out. So you are now going to buy all these components and now you use it for the customer. But if you had not done this, you wouldn't have known the right battery to put in the circuit or the right bulb. So I want to try and increase this value of the battery and see. And we all know what may happen if this battery is bigger than this bulb. So let me increase it to somehow maybe 15 volts or 20 volts. So let me take it back to the design mode. So when I do that, the transition stops. So I double click on the battery. Then the 12 volts here, I change it to 15 volts. You just type 15, then you go to enter. The 12 will be changed to what? 15. Then I do the same simulation. Let me send it to the simulation mode. Then I click on this. There's something you have to check. When it was 12 here, within this ball, there was no red line inside this. So let me take it back for you to see. So I'm taking it back to my 12 volts. Then we try and come to simulation mode. So you see within there, the line is black. It tells you that this is the normal brightness of the lights. But then if I try to take it back to design and change this one to maybe 15 volts, 15 volts, then I take it back to simulation mode and click the button. You see, the bulb has come brighter, but there's a red line in there telling you that this is not the correct battery to be used to power this lamp. So at the end of the day, you should expect danger with time. When you do this design for the customer, though the light will come, it will bright, everything will be nice for the user. But with time, the bulb can get faulty or it can get damaged totally, completely. Let's continue to increase this battery and see what will happen to the bulb. Maybe at the first design, when you started, you made this one 20 volts. So let me try 20 volts too and see what will happen in the initial stage. So let's send it to simulation mode, then we on it. I don't know whether you realize what happened here. When I try to on the switch, try and watch it. I'm going to do something. So let's take it back to design mode, send it back to what? Simulation mode. But let's just be watching this whilst I click on this. Immediately I click on, you see that the bulb has what? Fuse off. It has gotten damaged totally. So it tells you that never use 20 volts to power a 12 volts lamp. So when you are buying the components, always check their voltage range. If maybe you want to buy an IC to repair any components, check the voltage range. That is why sometimes the repellers in the roadside, they can damage some certain things forever because they don't know much into the labels that are found on the components. So they'll just say that so far as the shape is the same, oh, let me buy and put. Immediately you put it there and the voltage is not the same, it will get damaged. And one thing that another problem is caused by the sellers or the market women or the market men. What they do is that I was using a particular voltage regulator and IC to show to my electrical students. What I told them is that there is this IC called LM7805. Let me try and type it, then I share. Sorry, LM7805. Then we have LM7812. So these are the two different ICs. So let me share that part for you to see. So we have those. We have these two ICs. We have these two ICs. This IC takes in 5 volts. 5 volts. But this IC has the ability to withstand 12 volts. So this is what happens. When LM05 gets damaged in your television or your radio, you would like to take it to the market to go and buy a new one. When you go, the market woman will tell you that though there's no 5 volts, she might not be having, or he might not be having, and he wants you to buy. So why you tell you that, oh, oh, at the end, a number we inquire a different. Let me even use 09 here. 09. Let me use 09. It's a 09 that look much alike or much like what the 5 was. So they will just tell you that, oh, massa, it's the same, it's the same. It's just the 9 that is the difference. But everything to work, it work. And even when you check this shape, the shapes are the same. There's no difference. It's only this 9 here that is the difference. So immediately you bring it onto it, please, you are going to cause a lot of havoc. One, when you put in, yeah, let me do this. This is this one that got damaged, and you want to buy a new one, then the person say that go and buy this. Yes, because this one has the ability to withstand 9 volts. The radio is taking 9 volts, but then you bought this 5 volts, then you come and put it inside. You all know what will happen. At the end of the day, the power would damage this IC. That's the first problem. Secondly, maybe this IC is standing on the board, is standing in front of another component which is very costly or which is very critical. And when you destroy that component, the whole board is damaged. You have to buy a new board. So immediately the repeller put it there, that thing would get damaged. You can even damage about 5 sequential components, and that will be the end of your board. So they will tell you to go and buy a new board. At the end of the day, I don't think if you're a customer, you even go to the shop again because you didn't get what you needed. So you just stop and just go and buy a new one. That's what normally go on with the repellers. But it's very bad. So that is why we are trying to tell you how to always go by these kind of repairs. And when we get to the electronic industry, definitely you are going to meet some of these things. So uh, let me share my simulation environment again. So that is it as we are talking about. So that's a simple design. But then somebody will ask, I want to measure the voltage across this lamp and see whether truly it is 12 volts. So what we normally do is that we use a voltmeter. I told you. So you go back to this, just pick one of these. Go to source, then go to indicators. Voltmeter is there, ammeter is there. When I click on voltmeter, one of them is vertical.